So this is problem number 35 from the related rate section, and I wanted to make a video on this because it is a quite difficult problem. Difficult in the execution of it, but actually the concepts behind it, how we go about solving it, is exactly the same as all the others that we've done, and that is to identify exactly what we want to find out. Reading the problem says that we want to find out the rate which is angle is changing. We want to find theta prime, and it's based on this picture right here, and here's theta. So the idea is that we need to find an equation which relates some of these sides that includes theta that we would be able to take the derivative of so that we can generate a theta prime out of it. And what the book suggests is that we use the law of sines, which is the sine of A over the side A. So in this case we have the sine of theta divided by the length of the side. Now notice here that I have S is equal to 7.5 miles. This is going to be true after a half an hour of this thing, half an hour of this boat moving, but it is something which is changing, so I can't just put 7.5 there. I've got to put S. And then I also got the other side of it. This angle here is going to be 3 pi over 4 minus theta, and the way that I got that, it's 180 degrees minus the two angles. 180 degrees is pi, minus angle pi over 4, and then minus the angle theta. So the total 180 degrees minus the 2 angle gives the third angle, and of course pi minus pi over 4 is the 3 pi over 4 right there. So we get that sine of theta over S is equal to sine of 3 pi over 4 minus theta over 2. And then if I cross multiply, I'm going to end up with this next equation, which is 2 sine of theta equals S times the sine of 3 pi over 4 minus theta. And this is an equation which we get that has thetas in it. If I take the derivative with respect to time, I'm going to end up getting some theta primes out of it. And this is going to allow me to be able to find the answer that I want. The only thing I need to figure out, S prime, well actually S prime I know that, and S I know that. S prime is equal to 15 miles per hour. S is equal to 7.5 miles. So the only other thing I need to do is find theta. And once I find theta, I can plug everything in. The way we're going to find theta, first we're going to use the law of cosines, because what we have here is we have a side, angle, side, triangle, a side, angle, side. The way you solve a side, angle, side triangle is first use the law of cosines to find the third side, and second you've got to use the law of sines to find the smaller angle. If I were to find the larger angle, I'm going to end up getting an angle which is not obtuse, which is what I need here for theta. So, law of cosines. This is an application of the law of cosines right here. I end up getting y is equal to plus or minus, but I do end up getting the plus value of it because I'm talking about distance. I'm going to call that a in this formula down here. Use the law of sines to find the the smaller the angle. Here's the application of law of sines right here. I'll let you guys work through that, but essentially I'm getting the angle 3 pi over 4 minus theta is equal to the inverse sine of this. I've actually solved for the angle inside here. Once I do that, I have the ability to solve for theta, and I end up getting theta is equal to 2.12786 radians, and I'm going to call that B. So I have S. S was equal to 7.5. I have S prime, which is equal to 15. I plug in the angle B for theta. When I solve for theta